Okay, let's imagine that we're going to launch a pumpkin from a cannon at an angle of 35 degrees, but at a velocity of 17 meters per second. So this is an example of a projectile at an angle question, and we want to be able to see if we can find out the time that the pumpkin is in the air for and how far it travels, otherwise known as the range. So the first thing that we can do here is set up an X and Y chart, just like this. So let's go for uniform motion on the x-axis and accelerated motion on the y-axis. So we can just set this up. We want to find the range, we want to find the time, and we know that this is going to be v cosine theta for the x-axis and for the initial velocity, v sine theta for the y-axis initial velocity, and negative v sine theta for the y-axis final velocity. If the pumpkin goes all the way up and then all the way down, its displacement vertically is 0, and it accelerates at 9.81 meters per second squared. So we have our information, and we want to find the time. So we can just use these variables to start with, and then we can move the time into this axis to find the range. So let's get started with that. So the very first thing we could do is think about our vector diagram. So this would be V initial in y-axis, Vx, here's our angle, and here's the velocity of 17 meters per second. So let's find Vx, which is, as we mentioned before, that V cosine theta, which is 17 meters per second times cosine of 35 degrees. And V initial in the y direction is 17 meters per second times sine of 35 degrees, because that's the opposite side from the angle. So let's calculate these. Make sure you're on degree mode. 17 times cosine 35 is 13.93. We don't need to worry about significant digits yet. We'll just keep this written down as a few digits. And then 9.75 meters per second for the vertical velocity. Okay, so we've got those values. Let's go ahead and use our formula that includes the VI, VF, A, and T. And we'll solve for time. So time will be VF minus VI over A. So the final velocity, remember, is the negative of the initial. So in the y direction, 9.75 meters per second negative minus 9.75 meters per second, all divided by acceleration due to gravity. So let's calculate that. And I'll just use the answer function in the calculator. So I'll go negative answer minus answer, press enter, and divide by negative 9.81. So I get 1.97. So I'll just call that 1.9, 1.987. So 1.99 seconds. So there's the time that it's in the air. And if I want to find the range, I can just say D equals VT. And I know that horizontal component is 13.93 meters per second. And I'll multiply that by the 1.99 seconds. But I'll use the calculator answer. So just multiply by 13.93. And I get 27.69. But I have to just change this to 28 meters, or positive 28 meters, because I only have two significant digits. So let's just double check. I took a screenshot here, and it's 28 meters and 1.9 seconds there. Okay, perfect. See you.